All right, this is 9-2. This is your translations. So it says a translation is a transformation that moves all points of a figure the same distance in the same direction. A vector can be used to describe the distance and direction of the translation. So if you need to pause, you can pause it right now to write down what you need to fill in the blanks. I'm going to move on to this next little piece. So this next little piece here says draw the translation of the figure along the translation vector. So the vector tells me how, like the distance I'm moving my image and the direction I'm moving my image. So the best thing for y'all to do is take either like a piece of paper, a piece of like rip off on the little sticky notes, and you want to make it the length of that vector. And so what I'm going to do to show you on here is I'm actually going to copy the length of this vector and I'm actually going to cut this out. And what I'm going to do is I'm going to move it to each endpoint here because that tells me the direction and tells me the length. So I'm going to copy it. I'm going to do this 3 times. And again, you can pause this as you're doing your little sticky note and trying to figure out the length and all that other fun stuff. So what this becomes is this is going to be A prime. This will be C prime, and this will be B prime. So I'm going to go ahead and connect the dots. That should be right there. And that is that triangle translated in the direction and in the length of that vector. Alright, so now we're going to do translations in the coordinate plane. So first thing says a vector can be used to translate a figure on the coordinate plane when written in the form AB. A is your horizontal change, B is the vertical change. So we have a triangle. We're going to go ahead and plot the points. So we have 2, 5. So 2, 2, 4, 5 is right here in the middle. So there's Q. R 7, so 4, 6, 7, and then oops, I gotta go up 1. Don't need that dot there. So 7, 1. So there's R. And S is at -1, 2. So -1, +2. So there is S. And I'm going to go ahead and connect the dots. Okay, and so there is our triangle. So what we're going to do is we're going to write down these order pairs again. So Q, R, and S. So we have 2, 5, 7, 1, and -1, 2. And what this vector tells us, what we're going to do is we are going to subtract 1 from the x and subtract 2 from the y. So I'm going to rewrite these 7, -1. So we are subtracting 1 from our x. And then I'm going to write down my y's. So 5, 1, 2. And we are subtracting 2 from the y's. So now I will have a new order pair. So we're going to call this Q prime, R prime, and S prime. So 2 minus 1 is 1, 5 minus 2 is 3. 7 minus 1 is 6, 1 minus 2 is -1. -1 is -2, and 2 minus 2 is 0. So I'm going to plot those new order pairs onto our graph. So we have 1, 3, so there's 2, there's 3, so there's Q prime. R is 6, -1, 4, 6, -1, so there's R prime. And then S is -2, 0, so there is going to be S prime. So if you look at all of our new order pairs, you can tell they shifted down and to the left. And that is what happens when we subtract 1 from all of the x's and subtract 2 from the y's. And that's it. So we have one more to do. In this case, it is a parallelogram. So I'm going to plot my points. So we have 1, 6. So 1, 2, 4, 6. So there's A. B is 4, 5. So 4, 2, 4, 5. C is 1, -1, 1, -1, so C will be in here. D is -2, 0, so there is D. So I'm going to go ahead and connect the dots. Alright, so we have A, B, C, D. So we have 1, 6, 4, 5, 1, negative 1, negative 2, 0. And my vector here says, so what we're going to do is we're going to add 3 to the x and subtract 2 from the y. So I'm going to rewrite these. So we have 1, 4, 1, and negative 2. And I have to add 3 to my x's. And then I'll write down my y's. So 6, 5, negative 1, 0. And we have to subtract 2 from our y's. So once we do this, then we'll get our new order pairs. So we will have A prime, B prime, C prime, and D prime. So A prime is going to be 4, 4. B prime will be 7, 3. C prime will be 4, negative 3. D prime will be 1, negative 2. So I'll plot those and we're done. So A is 4, 4, so almost kind of crosses over there. B is 7, 3, so 7, 2, 3. So there's B. C is 4, negative 3, 4, negative 2, negative 3. And then D is 1, negative 2. So right there on top of that C. So again, oops, it's connecting to the wrong one. No, don't need that. You can see that our parallelogram here, it shifted over 3 to the positive 3 on the x, and it just went down 2 units on the y. Again, that comes from this vector right here. It says add 3 to your x's and subtract 2 from your y's. And I believe that is it, because this is the assigned -1. So that's it for translations.